In this video, we're going to talk about primitives and object data types in Java, and we're going to use that to illustrate the reference principle and discuss a little bit, introduce the jargon about value versus reference semantics that are used in the Java programming language. So let's start with a quick example, a very simple task that actually can go really wrong if you don't understand the way references are handled in Java and how they apply to object data types, but not primitive data type. So a quick reminder before we get started, a primitive data type is something like int. Like for example, in the slide here, we have a int right here, okay, int a initialized to 7. So variable a is of type data type int. It's a primitive data type. Lowercase starts the name of the primitive of all the primitive data types. So int a equals 7 and int b equals 35 are actually two variables of primitive data type int. If you have an object data type, that means that that variable is of a given class, is a reference to a given class, and you will notice that the name of the data type always starts with uppercase letter. So it's an easy way to distinguish between primitive data types in Java and object data types. Another way to distinguish between the two is that there is a finite set of primitive data types in Java: int, long, double, Boolean, and so forth. And then you have some object data type that come pretty much with the standard Java library, but you can also write your own class, and those classes become object data types as well, okay? So that's another way to distinguish between the two. Back to our little code example here, we have a main method. So we are assuming that it's embedded in a class. The class is not represented here to make the example a little shorter on the slide, but we have our public static void main method here, nothing new. Takes a string array of args parameter that is a string array. And we have two local variables here, a and b, of that data type int inside this method. And then we call another method that we're going to write in a second, okay? This method is called swap. We think that we pass variable a and b. And the intent of swap is that once we are done executing swap on a and b, we would like for the content of variable a, local variable a here that belongs to the main, and the content of local variable b here that also belongs to the main, to have been modified by the swap method. So that when we display again the value of a and a space and then the value of b right after, we are not going to get 7 and 35, but we are going to hopefully get 35 and 7. So as the name implies, swap is supposed to swap the content of two variables. And that is a big problem. So if you try this, I really encourage you to type this out and run it. If you try this, you are going to see that it's not working. At least the basic naive approach is not working. So what would be the basic naive approach? Well, you've learned already how to swap two variables. So let's go here in this swap method. If we have two local variables a and b, okay, here there are parameters, but for once again, forget about the swap method. Imagine that we are directly here in the main. So wherever we call swap, okay, we would use those three lines. So if we were using those three lines inside the main, instead of this call to swap, that would work, okay? We have an int temp assigned to a, so this is a temporary variable, same data type than a and b. We assign the value of a inside this temporary variable. So we save the value of a, the 7. Then we assign to variable a the content of variable b. So 35 assigned to a, okay, so now we move the 35 into a. And then we assign to b with the value we saved from a, that is in temp, which is 7. So if those three lines, again, if those three lines here were executed instead of this call to the swap method, and were returned directly in the main method right here, that would work. But now that we put them into a swap method, what's happening is that when we call the swap method, the parameters are a and b, but we are not passing the variables to swap. We are passing the values that are stored in the variable. So pretty much when we call swap a and b, we first replace a by its value, 7. We replace b by its value, 35. So we are making the call to swap, and swap receives two values, 7 and 35. It puts the first one in the first parameter, the second one in the second parameter. And in this example, the name of the parameters a and b are kind of confusing because they make us feel that maybe somehow this a here, this parameter a, is connected to that variable a, and absolutely not. Okay, we could have used as name parameter int x, int y. That would have worked. Of course, we would have had to modify the code here, but the point is that even if you were using the same name, those variable here in the main and those parameters for the method swap have nothing to do with one another. Okay, so it's often a misleading thing when you notice that parameters and variables have the same name to assume things. Well, these are the rules of scope. Okay, when you define local variable inside a method, for example, a and b inside of main here, those local variable belong to the main, and they cannot be visible outside of the main. Same thing here, when you have a local variable int temp in the swap method, it's local to the swap method, which means that from the main I cannot access temp, and from the swap method I cannot access a and b local variables from the main. But what I can do to enable the main to communicate, oops, sorry about that, what I can do to enable the main to communicate with pretty much the swap method, I can use parameters, and this is what we are dealing with here, right? We have actually a parameter here, a parameter b. So when we pass here the different a and b, we pass their values. These values are assigned to this version of a, this version of b that exists only in the swap method. Okay, so we have a 7 and a 35 here. And then, now you should understand that when we operate that swap, what we do really is we read the value inside of a, put it in temp. Perfect. But then when we write actually the value inside of a and replace it by the value inside of b, we are talking about this a and this b. So this code still indeed permutates the content of a and b, except that it permutates the content of parameter a and b, and that's it. So once we exit that swap method and return to the main, the a and b local variables inside the main have not been modified at all. Okay? So this is an important example because it's a very trivial task. Okay, if you are asked to write a swap function or a swap routine or a swap method in any language and you want to just swap the content of two variables, you would think that this is really trivial to do. Well, if you misunderstand how primitive data types are operating in Java, you will probably go to this kind of solution here. Okay, that is depicted as the bottom half of the slide. And this is not working because that is based on a property that you misunderstand if you are writing this kind of code. Okay, so what is that property? Well, we call that value semantics for primitive data types. Okay, so what does that mean? Semantics mean meaning, right? So that means that when you are assigning a variable that is of a primitive Java data type, we are assigning the content of that variable to another variable of the same data type, you are actually making a copy of the values that are the value that is in that primitive data type variable. Okay, so all primitive data type in Java use the value semantic. Okay, so that means that every time you assign, you copy the value. So if you have two variables that are both assigned 42, like you do something like, for example, let's take a quick example here, int x equal 5, okay, and then int y equal x, so both y and x are equal to 5, but they are each equal to the value 5, and they each contain a copy of the value 5. So it's not the same thing as saying that both x and y contain the same thing, the same object, the same entity, right? No, it's not the same thing at all. They contain the same value, but these are two separate copies of the value 5 in memory. And the bottom line is that if you modify one, for example, you modify variable y and you assign 17 to it, you can see that x and y are really still independent variables, even if for a brief moment they contained two separate copies of the same value, 5. So now we are back to x containing 5 and y containing 17, and so on and so forth. Okay, if I continue making assignment, like for example I assign 8 to x, I am not modifying at all the content of y. Okay, so this is what value semantics entails. This is what it means. Now let's take a look at the other type of semantics that we find in Java. So this is value semantics for primitive data types. Now we are going to talk about reference semantics for objects data type. So reference semantic means that we are going to be able to have two variables, and those two variables are going to be able to reference the same object, the same entity in memory. So modifying one of the variable modifies that entity, and because we have another variable that actually references the same entity in memory, while modifying via the first variable is going to affect also the second variable. Let's take a look to an example, okay? So in Java, like I said, object data types are anything that involves classes. It's also arrays. Arrays are objects data types. So let's take an example with an array. So this is an array. So the array itself is an object data type. It's an array of what? Well, I don't care. It could be an array of primitive data type, like in this example, an array of int. It could be an array of actually object over object, maybe an array of over arrays, okay? So it doesn't matter what you store inside of your array. The array itself is actually an object. Okay, so that means that when you assign an array to a variable, you assign actually a reference to that array, to that object. And a reference is pretty much a way to locate that thing in memory. Okay, so back to our example. We have an array of primitive data type int. This array is called A1. And we use a syntax here that allows Java to create an array for us on the fly and fill it already with values. So this is kind of a shortcut notation, okay, an initializer notation. So in this example, once we execute this line, we are going to have a variable A1, and this variable only contains actually a reference which tells us where we can find in memory this object. This is a whole object. This is an array object, and this array object has 3 elements inside of them. So in light gray here, you see the indexes of those elements. It always starts at 0. So 3 element means we have element index 0, 1, and 2. And inside the array object, we store obviously the values of those elements. So 4 goes here. 15 goes as second element at index 1. 8 goes as third element at index 2. And that's pretty much the memory diagram. That's a representation of what happens in memory when you define this variable A1 and initialize it. Okay? Now let's add a little bit to this example, and let's dig into what is interesting from the perspective of reference semantics. So let's define a second variable A2. Same data type, array of a bunch of elements, and those elements are of primitive data type int. And then we assign to A2, instead of initializing it with a new array and new values with the shortcut notation, we simply say that A2 is going to hold the same reference than A1. So here's the updated memory diagram here at the bottom of the slide. So whatever value was right here inside of A1 is going to be copied inside of A2. So please pay attention, okay? I use the word value and I use the word copied. So it sounds like I went back to what we were talking about previously. I did, okay? When I copy the content of A1 into A2, you will notice here that copying the content of this variable here into this variable here as well, it doesn't have nothing to do with the array, but this is not the same thing as copying the entire array. The array exists in one version, in one copy, here somewhere in memory. All I did is I put its reference in A1 to start off with, and now I'm copying the reference in A2. So you could say that the reference, and this is where it gets confusing, you could say that the reference is handled, the reference value is handled as a primitive data type, okay? So the value of a reference is copied around from one variable to another. So why do we talk about reference semantic and imply that it's somewhat different than primitive data type semantics? Well, it's because, yes, we do copy the value and we treat it as if it was a primitive data type, but notice here that the reference has a specific meaning, right? A reference means it's an indirect name for something located elsewhere in memory. Kind of like the address of something, okay? So when I copy the reference to this entity here, this array object, okay, this unique array object in memory, when I copy its reference, its address from A1 to A2, now, concretely, what I did is I allowed myself to access that array from A1 or from A2. So that doesn't happen when we manipulate an int. That doesn't happen when we manipulate a long, right? You copy an int value, well, you have two values, they have nothing to do with one another. You copy a long value, same thing, a double value, a float value, and so on and so forth, char value, and whatnot. But now, because we copy a reference, and the reference refers to a unique object, this has a different consequence, okay? So now, if we do things like, for example, A2 index 0 is assigned to 7. So this is a syntax to say, I want to assign the value 7. So the value 7 is of data type int because my array A2 contains a bunch of int. So I assign the right data type that this array is capable to contain, right? I assign the value 7 to my array reference to by variable A2 at index 0. So value 7 is going to be assigned to the array reference to by A2. So here's my variable A2. Inside of it, I have a reference to an object in memory. I follow that reference. I go to the memory location where this object is stored. And now I say I want to assign that value, the 7, at index 0. So here's index 0. This is where the value 7 is going to be stored. Okay? All right, so you see here the updated memory diagram again. Instead of a 4, now we have return 7 here. If we do a system.out.println, okay, and we want to display the array A1, okay, as a string, so system.out.println arrays, so we use a class named arrays. We use a static method in the class named arrays. So the static method is named toString, uppercase S, notice here. And we pass as parameter an array. And what this method of this class does for us, it's going to look inside this array and display its element on the screen with a nice formatted, with a nice format, pretty much. Square bracket around, separated by comma. So again, what happens here? Well, I call a method, right, with a parameter A1. So I look at the value of A1. What is the value of A1? Just like any variable, the value of a variable is the value that the variable contains, right? So in this case, A1 contains a simple value, which is called a reference to an array somewhere in memory. So this value is passed to toString. toString is going to use this value to locate this array object in memory, and is going to start displaying it, 7, 15, 8. Okay, so that's we are going to talk more about that, but we are using here the reference semantic again, but this time to pass a parameter to a method. Okay, so we use reference semantic here to assign two variables so that they point to the same pretty much array object. And now we're using reference semantic to let the toString method of the arrays class know about a specific array again in memory. So we use those references, those addresses, those pointers, we could call them, okay, as special values that represent where to find something in memory. And that allows us to share objects. For example, two variables here, both have access to the same object. For example, this toString method that is inside the class array has suddenly access to this A1 array that I defined in my main, for example. Okay? So, why do we bother? Why do we bother using that reference semantic? Well, I already mentioned the second point here, which is sharing. Okay? We're able to share things, have several variables that can access the same object. We are able, even more interesting, to pass object to methods so that those methods can access those objects. But we do so also with efficiency. Imagine that you have a large array of hundreds of thousands of elements. If every time you set a new variable to this array, you make an entire copy of the array, it's going to take time, it's going to consume memory. Same thing like if every time you pass this array to a method, and that method doesn't even need to modify the array, it just needs to access it, well, why make a copy? Why not give this method, a way to quickly and cheaply access the array wherever it is located in memory without making a copy of it, okay? So this is why you'll see sometimes people mentioning that this reference semantic enables a greater efficiency in your program, okay? So we have been talking about array. Everything we say about array, because arrays are object, is true for any other object data type. So for example here, if we have a class named drawing panel, and let's say that this class is a pretty hefty class, okay? It has a lot of code in it, a lot of fields that are stored in each of its objects, okay? So when we define a variable panel1 that is meant to contain the reference to an object of class drawing panel, and we create a new object of class drawing panel with some specific coordinate or properties, and we assign it to panel1, then panel1 contains a reference to that object. And that object, again, can be a very complex object. If we need to reference that object from elsewhere without making a full copy of all the data and fields in it, well, there we go, drawing panel, panel2 equal panel1. Same logic that we used previously with our int, arrays, now we can use with any object. And if we set panel2, if we use, panel2 to access this object and call a method that it features, for example, set background, well, it's going to affect, obviously, the object that is referenced to by both methods. So changing the color will affect both the object referenced to by panel1 and the one referred to by panel2 because they are the same singular object in memory. So, we talked already a little bit about this, but let's go back in more detail, okay? When we are passing object as parameters, we pass a reference to the object, which means that we implicitly share object. You remember in our first example in this video, when we discussed about trying to swap two int variable, we could not do that. Int, it was A and B were variable of primitive data type int, okay? You could actually mention them when you call a method, but all that happened is that their values, the value they contain, was copied and passed as parameters. So there was no way to alter A and B. Now, what if you have parameters and you pass values to those parameters, but now the values are references? Well, suddenly it's totally different because now you can use those references to access the object that is being referenced. So the method suddenly is empowered to modify an object that is passed to it. And you will hear people say, we pass the object by reference, okay? This is common jargon. So let's take an example. Here's a public static void main method, okay? We create another one of those drawing panel object. We assign it to a variable window, which is meant to contain a reference to a drawing panel. So we have the new object somewhere in memory, and a reference to it is assigned to the variable window. We use window to set the color background of that panel. For example, we set it to yellow. So here's what's going to happen. Here is our local variable window that is located inside the main. It refers to that object, and we call set background. So now the color of the background inside that drawing panel object is yellow. And then we call a method that we write ourselves, named example, and we pass as parameter window. What happens? Well, here's the code for that example method, public static void example, takes a reference to a drawing panel. When it gets a reference, so it gets the content of windows here, okay? The variable window has a value here, which is a reference. I pass this value, it's assigned to the parameter panel. So panel contains now the same reference than window. So it's kind of like what we had on the previous slide. We have two variables that point to the same object, except that one variable is in the scope of the main method. The other variable is in the scope of a separate method. So we have here a mechanism that allows indeed the example method to now have access to an object that is actually shared with the main. So it doesn't have access to a copy of something that the main sent. No, it has access to the very same object that the main is manipulating. So once we say, for example, panel does set background color cyan, There we go. This is a color that's going to be changed, the color of the shared object between the main and the example method. So same thing with arrays, okay? Arrays are also objects, all right? So that means that every time you pass an array to a method, no matter if it's an array of over object, an array of over arrays, or an array of something as simple as a primitive data type, okay? The array itself is an object. So every time you pass an array to a method, you are passing effectively by reference that array, meaning that the method is capable to modify the contents of that array. All right, so let's take an example. Here's the main method. So we have here a variable IQ that is a local variable to the main method that is meant to hold a reference to an array of int. And we use the shortcut notation that creates a new array object for us and shove inside of it 3 values. Okay, so now at this point, the IQ variable inside the main hold a reference that refers to this object here, this array object, that contains the int values 126, 167, and 95, like before. But now here's what we do. We call a method increase, which we are going to write in a second, and we pass the variable IQ. So like with any variable, when you pass a variable like this as effective parameter, you extract the value from that variable, but here it happens to be a reference. So that reference value is passed to the method increase, which code is right here. This method increase is meant to accept indeed a parameter a, which is of data type reference to an array of int. So that reference that we copied from IQ into a is the right data type. Okay, they are both referring to the same type of object. And now we have our parameter a, which is definitely existing only in the method increase, containing the same reference value than IQ, which means both a and IQ reference the same object in memory. And this is where the sharing happens. So now we have a simple for loop, okay? So for int I, this is our index variable. So I is initialized to 0. I is going to be tested to be lesser than the length of that array. So we use the attribute, the field length of the class array on the object referenced to by a. And then we, at each end of iteration, we increment I. So we pretty much iterate over index 0, then index 1, then index 2. And every time what we do is a at index I, so here's a, it's a reference, I go to the object it refers to, index I, the first index will be 0, I assign a index I times 2. So I take this value, I multiply it by 2, and I assign it here to the same cell inside the array. Okay, so I iterate over this array and I replace each value by its double. And this is what's going to happen. And of course, even though I modify this array using the parameter a, because the parameter a contains the same reference value than the variable IQ, the local variable IQ here, well, we refer to the same object, so it's the same thing that is being modified. So it's really important that you understand the difference between passing things by value and passing things by reference. Okay, that's the first very important thing. And when we come back after executing the increase method, we come back here and we display pretty much using the same trick than before, you know, the content of the array referenced to by the variable IQ. Well, this is the output we are going to get on the screen. Okay, so we effectively passed a reference to the array. So I said the first thing you need to understand is this sharing mechanism. Okay, so passing by value versus passing by reference. Now, be extremely careful, because what I'm going to explain now is a source of confusion. If you are asked at the lowest possible level, okay, when you look at what happens in memory, how does Java passes a parameter? Based on what I just told you, you are going to be tempted to respond, well, Java can pass a parameter in two ways, by value or by reference. Now, what I want you to think about is, I don't have any problem with saying that Java passes parameter by value. Okay, we are good on that, we are solid. But I ask you to think a little bit about what happens when you quote-unquote pass a parameter by reference. For example, here, it is legitimate to say that we passed the array referred to by IQ by reference, okay? So this array was passed to the method by reference. Okay, but again, if you look at what happened exactly, what happened in memory when you call increase IQ, well, yes, you are passing the array, but the way in which you are passing the array is by actually passing a value. What value is that? It's the value contained inside the variable IQ. So the same way that when we had a variable of type int, we passed actually as parameters the value inside that variable of type int, and we made a copy of that value. Here we are passing indeed the value inside the variable IQ, and we are making a copy of that value that is stored inside the parameter A. So this value that is here is stored in the parameter A. So really what we did is we passed something by value. But this is where the difference lies, okay? The something that we passed is a special something, it's a special value, it's a reference, okay? So can Java really do anything but pass copies of value when you call a method? No, that's all it knows how to do. But in order to enable Java to do the so-called, passing parameters that are object by reference, we have the special value that is called a reference. And when we pass that value and we make a copy of it, anytime we try to use that value, like anytime we try to use the parameter A, automatically Java will look at parameter A, realize that it's meant to be a reference. So instead of modifying this or reading this notation, the syntax here is going to tell it to go to that object first and then operate on one of the indexes. And that is why things are working. This is how we can pass primitive data types and reference, by values. But that allows us, when we do the latter, when we use reference passing by value, that enables us to pass actually the objects that are referenced by reference, okay? So we could just ignore, this little subtle distinction. But the problem is that while it's really easy to understand, oh yeah, passing by value is this and passing by reference is that, only if you really understand the subtle difference, you will have actually a complete mastery of the reference in Java and the passing of parameter. So it's really important that you make the extra effort to understand the somewhat, confusing statement. And I will welcome all of your questions on the forum, obviously, so that we can make sure that everybody understands the distinction in all its subtleties. Okay, and then we'll move on to the next topic.